Alright, so let's now take a look at the architecture of a Covnet. Now we're almost there. After we looked at an example, we will actually engage in our first coding session. But here at the entry you have a color image of 64 by 64 pixels, and then the times 3 is the number of channels. It's a color image. One of them is R, one of them is G, and one of them is B, red, green, blue. Okay. So then we have a convolutional layer, and in the convolutional layer we need to decide on some hyperparameters. There's actually 4. So the output of the convolution layer is what we call the feature map. Yeah? The number of parameters we need to choose is the number of filters, the size of the filters, the stride, and padding if we want to use padding. And then we have a ReLU layer that gives us the nonlinearity and also provides us with non-saturating gradients. Remember when we had the sigmoid curve for classification? Here you have saturating gradients. It's not very good because it's horizontal. Whereas here our gradient is constant for a net positive input. So this is a 0 here. For a net positive input, the gradient is constant. And that's why ReLU is so popular. And then we have a third feature here, which is pooling. We've not seen that. I will explain it in a minute. That's actually used to downsample the feature map. Yeah? Or in this case, the activation map, because we just executed a ReLU on it. And then at the end, we will use a fully connected layer, one or more, and then of course we have an output activation. In this case it could be sigmoid, which is this curve here. Yeah. So that's the overall, I would say, architecture. Now let's take a look at pooling. What is pooling? Well, pooling, we want to downsample. Yeah, we want to make the map smaller. There's no parameters in pooling. All the parameters come from the convolutional layer, the Covnet layer, and the fully connected layer. And we will see that the number of parameters coming from the fully connected layer is way higher than the ones coming from the Covnet layer. Yeah? Some people will include the pooling in the Covnet layer, other people will not. So this can be a little bit confusing, but I would say the Covnet layer is the combination of the 3, whereas the pooling layer actually does not add any parameters. Yeah? So in pooling we have 2 hyperparameters. We have our filter size and our stride. And our stride is often 2. So this is an image, and this is a 4 by 4 pixel image with values. And I will pool with a filter of 2 by 2 and a stride of 2. Yeah? So basically your first image is the upper left red corner. Yeah? Is this cell. And what are we going to do in this cell? Well, we're going to look for the maximum value if we do max pooling. So here we will do max pooling, here we will do average pooling. Max pooling is clearly the one that is used. I don't see a lot of average pooling. So in this case, the largest number here is 6. So we put here 6. In the second square, it's 5. Right? Then the lower left corner, 9. And the lower right corner, the largest one is 8. Okay? So we went from a 4 by 4 to a 2 by 2. Yeah? Every time we will do pooling with this type of a scenario where we have a stride of 2, well, basically you will divide these numbers by 2. Yeah? So average pooling is different, you just take the average. That is 4, 6 and 6 is 12, divided by 4 is 3. Yeah. 3 plus 5 is 8, divided by 4 is 2. 9 and 8 is 17, divided by 4 is 4.25. Yeah. And 8 and 7 is 15, divided by 4 is 3.75. Yeah. Alright, so let's now take a look at the Covnet layer, excluding the pooling layer. Yeah, let me put it here. So, well, I'm not going to write it. Yeah, you know that there's two conventions. Just to give you an idea how it works architecturally, you have a 6 by 6 by 3 color image. And here you convolve it with two filters. Yeah? And the filter has a size 3. So it's a 3 by 3 by 3 channel filter, both of them. And then we're gonna activate the output with a ReLU. And in a ReLU, we take the output of that filter, which is a 4 by 4, coming from a 6 by 6. Its N is 6 minus F is 3. 6 minus 3 is 3, plus 1 is 4. Remember, that's how we will, this comes from N minus F plus 1. So, how many parameters do we have? Well, each filter has 27. Yeah. So we have 3 times 3 times 3. Yeah. And then we're gonna add a bias. So we do that plus 1. So that equals 27 plus 1 is 28 parameters. Yeah. 28 parameters for this filter. If we add an extra filter, then we add 28. So total is 56. Yeah, you need to understand how we get there, because when we look at a more detailed example, we'll have to calculate how many parameters we have at each stage.